Are we in the correct direction for wind and all?
When I hear the word rocket, I hear it going up into space.
Make sure you push it in and all.
You see something that does just like an attention grabber, and that's how I first got interested into rockets.
Make sure they're not touching.
It doesn't matter.
Whenever we see rockets from NASA or SpaceX or anywhere, it's these huge machines.
8, 7.
Just the technology in that is just pretty crazy and just really cool to design.
39.9.
We're a club in Tesla STEM High School, and we're competing for the American Rocketry contest, and it's a nationwide rocket contest where teams around the nation compete. I added on the center of mass. I was really interested in aeronautics and rocketry and all. I really wanted to find like a rocket-based competition. Like I'm doing robotics and all, but especially I wanted to do something aerospace related.
If you even want to go down to 33, you can.
The best part so far for me would be the whole process of designing and developing it with my team.
We started out with just trying to figure out how to build a rocket. A lot of us, this is our first time, including mine, so I was just trying to learn like what makes a rocket. We got like these small rocket sets that are this long with very thin body tubes that already came with instructions how to build it, just to see like what that process is like on a smaller scale. And then we started using Open Rocket to try to design a rocket and buy the parts, just put it together and see what came out.
Spent the last few months every Wednesday working on the rockets. It's been really fun.
Hard part about any engineering process is the design. Building it just takes a few steps. That's not really that hard. But once we get that design down, it's just gonna work perfectly.
It was really fun for me because we were able to choose whatever motor we wanted to test it out with, and then we could run a simulation which will give us results on a graph, and it will give us hardcore data we could look at. And comparing these results with motors to find the cheapest and best option for us was really fun. When we were making it, we had one really big issue, fitting inside the weight limit. We wanted to do a lot of interesting things on our rocket, but because of the weight limit, we had to curb our interest and design parts of a rocket that were much lighter so that we could fit inside the limit.
I don't think this one does as good of a job.
Aren't you want to see if it fits?
There's a lot of work that goes into something that seems so simple on the outside, but in reality it goes through like rigorous testing. Okay, we installed this now. And you need to be like absolutely perfect on all your calculations, or else like, even the slightest mistake can have disastrous results.
So 640. Yeah, like 640.
I think that planes and rockets and space and all that is just really, really fascinating, but it's kind of still a mystery to me. I don't really know sort of like the physics behind it or the engineering behind it. This club and with this team, I'm hoping to just learn a little bit more about how to create a rocket and how to launch one and what that entails.
And make sure the two like metal parts aren't touching.
My goal, I don't care if the eggs crack, I just want the rocket to go.
The Rocketry competition outlines a few goals for us to achieve. First, a height, which is about 835 feet, if I'm not mistaken, and we also have to get within the range of 41 and 44 seconds of flight time.
We got off the ground fine, and the rocket flew, and the parachute did deploy. It got stuck a little bit, and now our rocket is stuck in a tree. Currently, we're trying to get the rocket down without damaging it too much. We'll have to assess the damage and see what's wrong with it and if it's fixable by tomorrow so we can get to the quality flight.
Since it's our first year doing this competition and just building rockets for most of us, we aren't really going into this with really high expectations, but this year is kind of like a pilot year for us. We're learning new things. We're finding out the best way to go through some of the design processes.
For our first launch, we just want to get it back safely. So we want to just make sure it works and like the parachute works. But after that, we want to fine tune it to make sure we can get like the parameters correct. And hopefully we're able to get close to the target parameters and hopefully advance to the national competition.
Yeah, they're touching each other.
Additionally, there are 2 eggs inside the rocket, 2 raw eggs, which we're trying not to crack and trying to bring back safely with the parachute and all. So just trying to keep a short flight time within the range and have an altitude that's on goal.
6, 5.
And make sure the rocket doesn't break on the way down.
It's still going.
So at the beginning, it was to get a good score and hopefully go to nationals, but right before this launch, it was to actually get a working rocket, which we accomplished. So I guess now it's just to fine-tuning it. But we are off by about 200 feet though, so we have to adjust that by looking at wind and also like adjusting the angle of our launch. We have to go home and fix this.